this is where we're at for today. So we've already done bivariate tables. So we're skipping into this. We're going to do actually ANOVAs today. So I'm adding this week, and we'll finish up chi-square. It just makes a little bit more sense that way. So we'll get that part done today, and I'll show you guys an example on how to run it in Excel. Then we have one more week of lecture, and then it's Thanksgiving week, and then the exam, which will include this final project as part of it. So we're really like down to the end. You guys have made it. Hopefully there's some sense of excitement about that you guys have gotten to hear. So yeah, just good to just check in on timeline. So let me take roll real quick. Haley.
Here.
Cole. Maybe Cole is not here today. Zach.
Here.
B. There. Hey, Zach. Savannah.
Here.
Eliza.
Here.
Bree.
Here.
Grace.
Here.
Greg D.
Here.
Emily.
Here.
Olympia.
Here.
Jenna.
Here.
Daniel. Yep. He's here. Greg M. Oh, actually, Greg, I think I see your back. Can you hear us?
Hi, I'm here. Sorry.
No, it's okay. Ashley?
Here.
Kyle?
Howdy.
Kind of in the dark there, Kyle. It's kind of a dark and gloomy day after yesterday. Saga?
Here.
Ada?
Here.
Elizabeth?
Here.
And Mary Pat?
I'm here.
Okay. So really, we're just missing Cole today. Check in. How is everybody feeling with the jump in numbers and all that? People feeling okay? I'm getting more notices of students who need to be off of campus. So it just makes me concerned for all of you. Hope you're all doing okay. Okay, so let's dive into the material for today. Like I said, we're going to be covering ANOVAs, and we will also be seeing how, oh, Cole is here. Hey, Cole. I marked you absent. I'm sorry. So we're going to be covering ANOVAs also on Excel, how to run that and what that looks like. So that's the goal for today. As I mentioned at the start of class, we have today for lecture, next week for lecture, then there's the Thanksgiving break, and we go into our exam. So we're right at the tail end of the class. You guys have managed quite well in this course, in this marathon that is taking statistics in the course of just one semester. It's always really, really fast. All right, so let's talk about analysis of variance. Just thinking of the title, what do you think this is going to be? What do you think analysis of variance is?
We're going to be looking at why things are, like, there is such a variety. Is it because, like, politics is an easy one, where there's multiple parties. Now, are these parties because of opinion or of need? Because, like, you know, the Green Party because of global warming and all of these differences.
Right. So definitely we're looking at variety and looking at differences. Analysis of variance is we are analyzing how two constructs or two variables vary alongside one another. The key piece about this is that it's going to give us a sense as to whether there's a difference between groups, but it's not going to tell us which one is more or less than the other. So the way we would do this is if you're doing an analysis, you've got a research project, and you're looking at multiple groups, you could start with an analysis of variance to see if there's a meaningful difference between groups. And if the answer is yes, then you can run t-tests between each of the groups. So this is why we go over t-tests first and then ANOVAs. So if we know how to do a t-test, then if we get a positive result for ANOVA saying there is a significant difference, then we can run a t-test between them. So that is going to be the goal for today. We're going to learn how to explain what is a one-way analysis of variance. The shorthand for that is ANOVA, because analysis of variance, hopefully that makes sense. It's the AN of analysis, O of, and the V of variance. We're going to define concepts of between and within total variance. We're going to see how to calculate and interpret it. I will walk you guys through how to do the analysis, like the calculation paper and pencil style, but as always, you are not expected to know that for any exam. You're expected to know how to do it in Excel. So we're going to spend some time talking about that today. And we're going to talk about the F ratio and the F statistic. As opposed to a t-test that's giving you a T statistic, the ANOVA gives us an F statistic. And obviously just ignore that. We're not interpreting SPSS output, but we'll interpret Excel output. They look exactly the same. It's in a table. It just won't be from SPSS. It'll be from Excel. So that is the goal for today. So an analysis of more than two groups. So a t-test, again, you're looking at two variables. Once you start looking at three or more variables, that's when an ANOVA would make the most sense. So again, we've talked about the analysis of two groups, right, with their means or before or after scores. But what happens if we're looking at more than two groups? So think back also, remember one of our first labs was looking at levels of education, men and women. Obviously, that's there's two groups right there, right? Gender split into two. But then we also looked at racial groups, right? And then levels of education. So that was more than two. So what we ended up doing that was the crosstab, which is a descriptive statistic. It describes the frequency between those groups. If we wanted to know if there was a significant difference in the means of those groups, we wouldn't be able to do that with a t-test unless we ran three separate t-tests, right? Because you need to do two and then two again. I don't know if this makes sense what I'm doing. You'd have to check the combination of two variables between all three variables. But if you did an ANOVA, you'd be able to see if there was actually a significant difference in the means of those three groups. So as I mentioned, a t-test is not capable of handling more than two groups or two sets of scores. So because of that, then steps in a new analysis, specifically an ANOVA. Well, this is very similar. This is different data than what I've given you guys, but it's the same idea. So in this particular example, when we've got 4 different racial groups and educational attainment for each, you can see the N here for each of them. How could we calculate if there's a difference in the educational attainment between those 4 demographics, right? Like, how could we do that? Again, if we did t-tests, we'd have to do white and not versus, but like the 2 variables. So white and black first, maybe, or whenever, right? This, then white Asian, white Latino, then you go back again, black Asian, black Latino, and then Latino and Asian together so that all groups are represented. So that is a ton of t-tests that you would have to run in order to see if there was a difference. The beauty of ANOVA is, what's that?
Sorry, could I ask a quick question? I'm not sure if this is even relevant, but what does the N1 = 6 represent?
So these are the different samples. So this is the sample 1, sample 2, sample 3, sample 4. So that's why it's N1, N2, N3, N4. And then the 6 is the number that's in the sample size. So in the white group, there's 6 individuals that were commented. So like this table's not even filled in, but this is just to give you a snapshot. We're not calculating this.
Okay.
In the black category, there's 5 respondents. Asian, there's 6. Latino, there's 6.
Okay, thank you.
Yeah, no problem. Okay, so again, having to run multiple t-tests, not the end of the world, but if there's a way to do it easier, right, we want to do that. So an ANOVA is an inferential statistics technique that is designed to test for significant relationships between two variables in two or more samples. So again, it's the exact same thinking as a t-test, but we're extending to independent variables that are in two or more samples. The goal of an ANOVA is to examine the difference between the samples and within a single sample. So it can do both between and within. And then that difference that we measure is often referred to as variance or variation, which is why then ANOVA is an analysis of that variance. Whoops, daisy, sorry about that. All right, so multiple different ways that we can do the test. So a one-way ANOVA is a procedure using one dependent and one independent variable. A two-way ANOVA is the same idea, analysis of variance, but it's using one dependent and then two dependent variables. That's also known as a factorial ANOVA, and oftentimes you'll see it, see how it says 2 by 2 or 2 by 3. I think I drew this out actually for my other class the other day. Let me just pull that up. Okay, maybe actually it was with your class last week when we did this. Okay. So this would be considered a 2 by 2 because the one variable here has two options and the other variable here has two options. When you see here it says 2 by 3, it would be if I added another category here. Okay. You guys see that? So it's adding. So there's 2 here and then now there's 3 down, going down. Okay. So it depends again on what is the variable that you're using, but that's how you could do that, a 2 by 2 or 2 by 3. A three-way ANOVA, same idea, it's one dependent and 3 independent variables. That's another measure of factorial ANOVA. So you can see now you're doing 2 by 2 by 2. So you're almost making it into a cube. There's like a third dimension in a way, not really, but it's 3 variables looking at it together. And then there's several others. You could do a repeated measure ANOVA, a MANOVA, which is a multiple analysis of variance. ANCOVA, that's about covariance rather than just variance. So we're not going to worry too much about that. But if you see that language in a textbook or you're reading a research article and that's the language they're using, just know, bottom line, they are comparing, they're seeing if there's a difference between multiple samples and a dependent and independent variable. That's the crux of it. They're looking at the variance of it. Okay. So when you're creating a hypothesis, which again, that's how we're looking at statistics in the social sciences, right? It's for research purposes. So there's a few assumptions that we need to have, much like any of the other analyses that we've done. First, the independent random samples are used. So our choice of sample members from one population has no effect on the choice of sample members in the other, third, fourth, whatever population that you're getting. So for example, the selection of Asians has no effects on the selection of any other sample in the example from before. So me selecting from that group is not going to impact my selection of those in the Latino group, Black group, white group, etc. Okay? And the dependent variable is measured at the interval ratio level. This cannot be at the nominal level. We need to have actual data to see the difference. And you'll see it's because we're comparing means, so we need an actual value for that. All right. Other assumptions we need to keep in mind, much like almost every other analysis we've done in this course, the population needs to be normally distributed, and the population variances, we're assuming that the variances are equal. So again, 2 assumptions going into this analysis. So the way we would state the research and the null hypothesis would be this way. The null hypothesis, which quick reminder, null is H sub 0, that's the null hypothesis. It presumes that there is no difference between the means, right? These are the population means, right? This is a mu. So it's saying the mean of one group will be the same as the second, the third, and the fourth. There is no difference between them. Now, we will not be able to tell which one is greater or less than. The question with an ANOVA is really just, is there a difference between the groups? So because of that, your alternate hypothesis is just that at least one mean is different from the other. So another nomenclature you may see is that mu1 does not equal. So it would be like the equal with a line through it. Does not equal mu2, does not equal mu3, does not equal mu4. Somehow inserting in there that they are not, in fact, all equal. So that's another way to say this is it can only tell us if there's at least one difference. It will not tell us which groups are different. So that's important to know. It just gives us a quick glance at whether there's a difference. In order to determine whether there's group differences between subgroups, you have to conduct planned comparison or what's considered post hoc comparison. So if this was your original hypothesis and you found that there was in fact a difference between the means, then you could do further testing, t-test between levels to see if in fact which one is greater or less than. And it doesn't have to be part of your original hypothesis. It could just be a post hoc analysis, meaning I discovered something was significant. Now I'm going to do a little bit more analysis to get to the root of what is different. Okay, so that's that. Questions about that so far? So what is the purpose of an ANOVA? Again, we're not finding out why it's different. We're not finding out which of the two is different. We're just saying it's not different. Okay, if there's questions, please do let me know.
So we
Okay.
are only working with, just in terms of the test, we're only working with ANOVAs, right? We just need to be relatively familiar with like a MANOVA and stuff like that.
Yes, I just want you to have like an awareness of the word exists. That's all you need to know about MANOVA, ANCOVAs, and MANCOVAs. That's it.
Okay.
No, the focus is really only on ANOVAs, yes. Okay, so to calculate that, we're going to need to look at the concepts of between and within total variance. So between group, sum of square is going to be noticed, this is how it's going to be noted, SSB, so sum of squares for between groups. It measures the difference in average years, so again with our example of education and race. So measures the difference in average years of education between our four groups. The sum of squares is the abbreviation for sum of squared deviation. So again, think of deviation and variance. Those are very similar terms, right? Because in fact, the standard deviation is your variance just square rooted, right? So those are kind of interchangeable. So for SSB, what we're measuring is the sum of square deviation between each sample mean to the overall mean score. So what does that actually look like? We're going to look at a formula in just a minute. So that's for SSB. Now we're going to do at SSW. Those are the within group sums of square, which is a variation of scores with a single sample, or in our specific example is the variation in years of educational within one racial group, right? So you're looking across and you're looking within. It's also referred to as the amount of unexplained variance, and this is what remains after we consider the effect of the specified independent variable. So what does it look like? This is our sum of square between group. Again, nomenclature that you don't really need to memorize for this class because we're going to do a practice on how to do it. But the idea, again, is you could see you are summing the number of cases in our sample. K represents a number of different samples, okay? This is the mean of a sample, and this is the overall mean, right? So you do the difference between those, square it, do a multiplication with the number of cases in the sample, and you do a sum of all of that as you go through. Okay. Now, within group, very, very similar. You're going to be looking again, same idea. This is the sum, right? You're summing the difference between each individual score in a sample minus the mean of a sample squared. Or, this is another way to look at it, but that you're looking at, again, variation. This should look similar to a standard deviation, right? So we're looking at the difference or the variation within each group to see how much variance there is, okay? And then the total sum of squared, that's SST, is the total variation in scores calculated by adding the sum of square between groups and the sum of square within groups, okay? So it's this calculation here, your total SSB plus SSW. So that is what we are trying to calculate, and that's how we're arriving at our F statistic. We'll talk about that in just a second. So degrees of freedom comes back, right? Degrees of freedom is the number of it's the number in our specific sample, and we usually do -1. So we're going to be calculating 2 degrees of freedom, because first we need to look at between groups, and then we'll look at within groups. For those that are between groups, you determine it by the number of categories there are -1, or the number of samples or groups that you have. So for us, if we're using the 4 racial groups as before, it'd be 4 minus 1. So degrees of freedom would be 3. Now, within groups, that's determined by the number of total cases minus the number of groups. So we have 4 groups. Let's say we had 100 individuals in our sample, it'd be 100 minus 4. And that's for the degrees of freedom within groups. Okay? All right. So next, what we want to do is figure out, what does it meet our hypothesis, right? Is there a significant difference? Is there actually a difference between the means? So the mean square between is, again, the sum of square between divided by its corresponding degrees of freedom. And then for the mean square within, you're doing the sums of squares within divided by its corresponding degrees of freedom. And again, we figured out our degrees of freedom for the within group is this, and for between group is that. All right. So the mean square between group, you're looking at an estimate of the variance that's obtained by dividing the between group sum of square by its degrees of freedom. We just said that. So it's your SSB divided by degrees of freedom for between groups. Again, that's going to be the number of groups you have minus 1. Mean square within, you're doing the same thing. The sums of square within divided by the degrees of freedom within, which is your total sample minus the number of groups as identified right here. Okay. Now,
can I be completely honest really quick? I'm a little intimidated by, like, there's
a lot. I'm giving, this is all the stats background. We are going to do a 3-button calculation on Excel.
Okay.
So I have to go through all of that because our department has decided you guys should know this information. I think you need to know it like on a bird's eye view level. You need to know how to do it in Excel, and you need to know why you would do it. Those are the 2 things I want you to know.
It'll be more familiar to us when we can see it on Excel, is what you're saying?
Yes.
Okay.
So I'm just coming up with all of the reasoning as to what you get when you get your F statistic, because that's what Excel is going to, spew out at you.
Okay, got it.
So the F statistics, much like when you guys did a t-test, you got a T statistic, right? Or when you get a mean, you need to know how you got that calculation. The F statistic, this is how you get there. It's the ratio between group variance to within group variance. So in order to get to that, we need to know a few steps back. So once you know your between group variance, which is your sums of square between groups divided by degrees of freedom, you're going to do that over your sums of square within groups divided by the degrees of freedom. That value, the ratio that you get, that is your F statistic. Okay? It is going to be, well, let's talk about it a little bit here. The F statistic is, it's used, again, for ANOVAs. It represents exactly what I just said, the between group variance to within group variance. You're going to have the F obtained. That's the value that comes from the calculation, right? So doing this ratio gives you this F obtained. That's your F statistic. That's the actual test statistic. And then you need to know your F critical. This should be kind of a buzzword in your mind, right? Critical value. Kind of like with Z or with T, we had a critical value where we said at this level of significance, we feel confident that if you reach this point or bigger, we know it's going to be a statistically significant result or conclusion. So The F critical is the F score associated with a particular alpha level, right? What's the alpha level we usually use, guys? Almost every single time.
Well, 0.05.
Yep. That is the alpha level we use almost every single time. Another way to say it is the 95% confident level, right? But your alpha level is 0.05. So the F critical is a value that you will get once you plug into a chart, same as we've done before. You won't even need to do that for this because the Excel just spits out the F critical too. So then you just do a comparison of the two numbers. So the F critical is a combination of the alpha level you've decided beforehand, 0.05 is the most often used, and the number of degrees of freedom that you have in your sample. So those two, right? Remember, like for T and Z, like it's a big table, you go down and you get an F critical. That value is what you compare to your F obtained. And if your F obtained is greater than your F critical, you know you have a statistically significant result. In this case, what would that mean? It would mean there is a significant difference between the groups. The groups are not even. Now, would we be able to tell which group is higher, which group is lower? The answer is no. We don't know that. We just, with the F statistic and an ANOVA, all we know is that they're not equal. That's the only answer we really get from that analysis. If I want to know more or which directionality it goes, I need to do multiple t-tests to then divide up each group to better understand how one compares to the other. Okay? Okay, so let's look at what this looks like. F critical versus F obtained. This should look familiar again with T critical. So our F critical, this is a random example, with an alpha of 0.05. The F critical was 3.13. The F obtained is 3.97. Therefore, it is a statistically significant result. The way I would summarize that is that I can reject the null hypothesis, right, that all means are equal. Okay, this is an example from your text. I think that relates to the years of education and race. You can go back to that example in your book. So again, here's a summary of what we did. So an analysis of variance examines the difference between 4 demographic groups and the average years of education, just like we talked about at the beginning of class. There are some assumptions we have to make with that specific type of analysis. 1, independent random samples are used, meaning picking somebody being in one group has not impacted them being in another group. The dependent variable has to be an interval ratio level. This one is years of education, so that's a number that works. The population are normally distributed and the population variances are assumed to be equal. Those are the assumptions we're making with an ANOVA, okay? Next, we present our hypothesis. The null hypothesis is that there will be no difference in the years of education between each racial group. The alternate hypothesis, or your research hypothesis, is that at least one mean is going to be different than the others. And I am setting up the bar that the alpha has to be at 0.05. Okay, that's my 95% confidence again. Next, you're going to be selecting the sampling distribution and specifying which test statistic you're doing. In this, we're going to be using an F distribution because we're doing an ANOVA, and that's what we use with an ANOVA. Next, you compute the statistic. Now, we have some data to go from. Your book has a lot more information on this, but this is the snapshot picture so you guys see how numbers fit in. So you at least have some concept of what it looks like, so it's not just abstract. So first, you would calculate the between group and then the within group variation. This is estimated at 63.3 for between groups, with degrees of freedom is 3, which we knew already, right? Degrees of freedom is total number of groups minus 1. So 4 minus 1 is 3. And then within groups, the sums of square is 62.03. Degrees of freedom is your total number, which I think was 1824, I think, or 23. minus the total number of groups. So yeah, I guess I could figure that out. 19 plus 4, 23. Then you calculate the F statistic. So it's literally sums of square B divided by my degrees of freedom. Here it is. Sums of square within groups divided by the degrees of freedom. Here it is. I get 21.01, and I need to figure out my F statistic. If we go back, sorry, I'm going to go fast real quick just so we can go back so we remember how we did that. The ratio is right here. Minus, there we go. We're dividing it then, ends up at 6.44. Now let's look at the graph. Man, that's a lot of information. We're going to skip that. Oh, I thought I put it on here. I didn't put it on here. Oh, there it is. It's right here. Our F obtained, 6.44, is greater than the critical, which was 3.13. Okay, so my critical, you can always draw it out too. Find your critical, which again, Excel just gives it to you, so we don't need to panic on how to find it. Here's your F critical. It is way above that. Therefore, we can reject the null hypothesis and conclude that the groups are different in their educational attainment. So we just know that there is difference. We don't know higher, which of the group is most different. We just know that there's a difference, okay? If we wanted to do additional pieces with that, we would then create t-test analyses to get to the bottom of it. Okay, this is a very theoretical. ANOVAs are kind of their own beast. Questions, confusions I can help with
Could you
before we jump into Excel.
one slide? I just couldn't write fast enough.
Which slide? This one?
That one. Perfect.
So that's this calculation, 63.03 divided by 3, 21.1, divided by 6203 divided by 19, which is 3.26, which gives us 6.44.
Awesome. Thank you.
But again, you won't be doing any plugging and chugging for this class. You'll just be doing click, 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 click. All right. So I was hoping we could do an example in class all together at the same time to try to congeal this information. So my first question is, does everyone have access to Excel? Like right now-ish?
I do.
Yeah.
Yes.
Okay. Yes. I'm hearing people in the chat. Yes, yes. Super. So what I would like us to do is open up Excel. Let me share my Excel spreadsheet here. Here it is. Oh, do you guys still see me? Yeah. Do you see Excel? Somehow it went on my
Yep.
other screen, so I'm not sure. Okay. You see business, admin, psychology, sociology?
Yeah.
Yeah, okay. If you guys, oh, my screen sharing is paused. Why did I do that? That was an accident. If you guys want to take a moment and fill in the same categories, this was a fun data piece from 2014, I think it was average salaries of individuals. They're 10 years post their degree. This was their major for their bachelor's degree, and this is their current income. So it's not $42, it's $42,000. I just deleted all the extra zeros because that just makes things a little easier. So don't despair if you're like, wait, what? This is your yearly salary? Okay, so if you guys want to write this in, this way we can do it all at the same time. So note that there are more responses for business administration and sociology than there are for psychology, but that is fine. So step one, just reproduce this table. And then either give me a thumbs up or say done once you have this all done. Okay, we got a few that are done.
I'm good.
Okay. Okay. Now, question for you guys. What is the dependent variable?
Salary.
Yes, salary or income. And what is the independent variable?
The major.
Exactly. Okay. So the first thing I need to do to analyze this data is to go into data. Oops, I'm going to need to move your faces. Okay. Now, does everyone have this analysis spot or data analysis section?
I'm not seeing it.
Okay. It's possible you may not have it, and luckily it's free and it's a very quick thing to do. So let's walk through it together. If you don't have it, what you would want to do is go to File. Can you guys still see as I'm clicking things? It's popping up windows?
Yep.
Okay. Scroll down all the way to the bottom to More and go into Options. Okay, does everybody get this section here?
I think it's different on my Mac. Where I
That is
can't
quite
get-
possible. I am Mac dumb. So you have a Mac, and so you don't have this button. You don't have an add-ins option.
I don't know. And also it's, I don't even
Is it numbers, not Excel?
I have home and insert and page layout, but not file.
Yeah, I don't have file either.
Yeah.
Okay, so if you have a
So
Mac, sorry, I Googled
Yeah.
this. I think that if you go to insert and then the fourth section says add-ins and office add-ins, I think that might be where,
the way to do it.
yeah.
Add-ins. So is it my add-ins with a little cloud on it?
Mine's
Oh.
office add-ins and it's like an octagon, just two different octagons. It's on the insert tab.
Well, let me finish this example for maybe no one who has a PC. If you're over the age of 24. Anyway, this is what you would do. You'd click add-ins over here, manage Excel add-ins. You'd go to Go, and you'd want to make sure that you've got Analysis Tool Pack selected, and you'd press OK. All right. Now, Kyle, you're saying yours is under Insert. Yeah, your Insert probably. Oh, this, My Add-ins.
Yeah, I don't know. I don't know if this is really. Yeah, that's it. I
Oh
just
yeah. Okay. So this takes you to the same place I just was. So if you go to My Add-ins, Manage Other Add-ins, and you go down here, Manage Excel Add-ins, Go,
So
Analysis Tool Pack.
So all that I have when I click exactly what you clicked is just see all. And then basically it tells me no add-ins, get add-ins for your account. That might just be me.
No, I'm also getting that as well.
Yeah.
Yeah, because this should be free. Okay, so the other thing you could do you guys have the little light bulb right here? For the
Yes.
help?
Yes.
Analysis Tool Pack. Can you type that? And then click it. Do you guys see that option?
I don't, but I don't want to bog everybody down. So I can, just not right now, but I can get access to Excel on a non-Mac.
Okay.
So I'll just, well, I don't know about everybody else. So maybe.
I mean,
Ada,
I'm
do you have the
having-
same problem?
Yeah, I'm having the same problem.
So when you go to the light bulb, can you type in analysis toolpack?
Okay, yeah. One sec.
Wait, is that what we need under data analysis? Is
Yes, that's all you need. Analysis toolpack.
well, I have a Mac and
Oh, you're muted.
About to
Oh
drop
my gosh.
a piece of information.
hello.
Okay. Hello. Okay.
I downloaded Excel on my Mac and I've had it. And when I go to data, there's something called analysis tools all the way on the right. And then it says add-ins available.
Oh.
Does it look like this,
Oh,
Daniel?
yeah.
Oh, you got it.
Me too.
So you click
Woohoo!
data, you click
The
data
rescue.
analysis, and then what? Yeah. Oh my gosh. Thank you, Daniel.
Kyle, you still look confused. Does it not work for you?
Trying to find it. Okay, so
So under data,
data.
totally at the right should
And then
be.
to the far right, it should be analysis tools. Should be a big gear.
Okay, I have flash fill, the data tools, then outline, the group and ungroup, and then blank. Excel is
This is why this is why I'm always like, look at YouTube, because we all have slightly different versions, right? And so, and Kyle, you tried typing in analysis tool pack into the little light bulb and nothing came up.
nothing.
What about add-ins? If you just type in add-ins.
Yes. Okay. It just gets me to insert office add-ins. And that is where we started from. Okay. You guys
Okay.
continue, and I'll be doing this, but also paying attention.
Okay. All right. So if all of you have this button now, data analysis, you click it, and it gives you several more sophisticated analysis that you can run, right? So we've got some t-tests down here. We have a regression button, which we'll use. You can create a histogram from it. But at the very top, you have ANOVA single factor. So Mac friends, do you guys all have this window that popped up?
Yep.
Super duper. You will then click OK. Next, this probably won't be filled in for you guys, but I ran this analysis earlier, so that's why it's in. But the way you would do that is you click here and you want to select, starting at cell A2, all the way down to cell C10. Okay. Next, you'll want to make sure that your alpha level is set to 0.05. That's the default, so that's what it should be. And then select your output range. Now, I like it when it's on the same sheet. If you prefer a new worksheet, you could do that too. I just selected E1 right here so that it would pop right there. Okay. Now, if I click OK, I get this table. Okay. Need to move your faces. Okay. So first thing you'll notice about this output is it gives you, first of all, the frequency into each of the groups. So you know that there's 9 in the business admin group, 7 in psychology, 9 in sociology. You get here, there's sums of square. Remember we talked about that, like when we did the calculation? That's how they got that. This is the mean. This is the mean salary here. So just eyeballing it, right, which we probably shouldn't do, but eyeballing it, you guys probably already note that there seems to be a difference between salaries, right?
Yeah.
Yes, those numbers are different. Okay. Now we want to then go to the specific ANOVA. Here's our sums of squares between groups. So this is our SSB. This is our SSW. Okay. These are the degrees of freedom between groups. So we have 3 groups minus 1. That gives us 2 degrees of freedom. We have here for within groups, remember we take our entire N, which is all of this together. So that's 1826, right? 1825. I can do math. It's hard, said the stats teacher. Don't lose faith. So 25, right? That's my total N minus the number of categories or groups, which is 3, right? Which gives me degrees of freedom 22. And then you are doing the sums of square divided by the degrees of freedom, right? Just like we did earlier. That gives us 542 for between groups. 786 divided by 22 is 35.72. And lastly, you divide these two, between groups divided by within groups, which gives you an F ratio of 15.20 if we round up. Okay? Now this already gives you your F critical. So your F critical is 3.44. Picture again, you know, your normal curve, 3.44, and our F ratio is 15.20. So is it significant?
Yes.
Yes, very, very much so, okay? Whenever you're F critical, just like a T critical, that's the smallest value that shows significant. Anything above that, super significant. That's gravy. So our F critical is 3.44. Our F ratio is 15.20, so very significant. In fact, look at this p-value. This is an itty-bitty p-value. Remember, with significance, we set our alpha to what?
95.
Right, or 0.05, right? Our alpha was 0.05, and we said at this point, anything that's smaller than that, super significant, right? Because that's the amount of error. I've said I am comfortable with this amount of error within my response, 5%. That's what I'm comfortable with. Or flip it on its head. I want to be 95% confident of my response. The p-value for this, if I move the decimal points, would be 0. What is that? 23716.
So with that, we're looking at the F value to calculate that? Or to...
Let me take a step. So remember our p-value, that's how sure we are that it's not due to random error, right? So we set our alpha at the beginning, that was 0.05. If we reach that level, 0.05, that anything more than 0.05, that's too much error. We said, then we're not so sure. Then we're not so certain about the results that we get. We want 5% error or less. That's what we set it with our alpha. So when we get a p-value of 0.0000716, that's not 5% error. That's less than 0.001 error. That's very good. That means we feel very confident that we can reject the null hypothesis, that the means of salary based on degree is in fact not equal.
Okay.
Okay, questions about this?
Can you show me again really quick how you got those two tables up there?
Absolutely, let's do it again. I'm gonna just copy this, if you guys don't mind, into a new sheet. Okay, this way we all start at the same spot. So you go, I'm gonna take your faces away real quick so that when it records, see more. So you go into data. Oops, they're still in the way, how's that possible? All the way to data analysis. You then select ANOVA single factor. first you need to put your input range. This, because I've done it, it already puts it in. But you would select, right, from A2 all the way to C10. Okay? Because those are the values you're looking at. Your alpha level, this should be the default level, 0.05. If it's not, make sure that you switch it to 0.05. Okay? Next, my output range, that's just where I want the output. I just picked the cell, you know, now I'm gonna confuse it because I have a double. You could do a new worksheet, that's fine. I just like it right next to it. And then you click OK. Uh-oh, and now I made it angry. Oh, I have an extra. Here. And then I don't like it when words don't take those, so I usually just make it fit, and it makes me happy. So that is how I got here. Ada, did that help?
Yeah, thanks.
Okay. Is it the same on your Mac?
Yeah, I'm going through it right now. I'm pretty sure it is.
Okay, super. Other questions?
Do we care about the decimals? Like, are we going to ever have to format it where it's just 2, like where we cut it down to only 2 decimals? Okay, cool.
No, just leave it like that.
Awesome.
So what you need to know for exams and just general learning, the takeaways from ANOVAs, is it looks at the difference. Again, we're looking at differences in mean and the variation between different groups, right? We're analyzing the variance between groups to determine if they are all equal or if they are unequal. That's really the only question we can answer. We cannot answer which one is higher or lower, right? Like, we can't parse them out. We're just looking at, is it all equal, which would be your null hypothesis. Mean sub 1 equals mean sub 2 equals mean sub 3 equals mean sub 4, or are they unequal, meaning there's at least one that's different. The way we do that is by categorizing things, right? I look at my means for each of them, the variance. You don't even need to care, I mean, right? Like, I remember when I was teaching this class last year and I had my students actually calculate this, but since you guys are not in class, we're just gonna Excel it up 1,000%. So you look at the variance, you then come up with the sums of squares between your groups and within your groups. I need you guys to know, again, degrees of freedom, right? One is the difference, each number of groups minus 1. The other one is the total sample minus the number of groups. That's how we get 22. You then figure out the ratio between those two. Again, 1085 divided by 2, 786 divided by 22. You then divide these two values, which is how you get your F statistic. What you need to know, you don't need to know how to calculate any of this. Excel just spits it out for you. What you guys need to be able to do is, if you have a table like this, you need to be able to tell me if, 1, is the result statistically significant, right? And we look to the p-value for that. Another way you can look at it is your F obtained, your F value, is it greater than your F critical? Okay, both of those will get you the same response. And then, do you reject the null hypothesis or do you fail to reject the null hypothesis? And you would be able to answer that by knowing whether it's significant or not.
Now, in this situation, it is rejecting the null hypothesis, correct?
Yes.
Thank you.
If you have a significant finding, you will reject the null hypothesis. Yeah.
Okay, just the null hypothesis stuff kind of confuses me, and so I'm happy that I'm on the right track.
So another way to think about that, because you're probably not alone in this, is that your null hypothesis means nothing is different. It's all the same. Same with T, right? A T-test. The null hypothesis is saying they're exactly the same. There's no difference. It's status quo. Your research or your alternate hypothesis then says there is actually a difference. right? With a t-test, you could say one is greater than the other. With an ANOVA, we can't do that. We could just say they're not equal to one another. So when you get a significant result, that tells you they're not equal. They're actually different. So because of that, we have to reject the null hypothesis.
Okay.
And our statement, like the APA statement, only responds to the null hypothesis. It does not say anything about the alternate hypothesis. So you reject the null or you fail to reject the null. You never say, I accept the research hypothesis or I accept the alternate. You wouldn't say that. You just speak to the null hypothesis.
So one more time, where do we look? So we failed to reject the null because
we have a statistically significant result. I know that because of two things. My F obtained, my result, my F statistics is larger than my F critical.
Okay, just wanted to check.
And my p-value is smaller, like I was showing on this sheet here. This was what I said I accepted as error with my alpha, 0.05. This is way, 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 way smaller. So because of those two things, they really go hand in hand. I reject the null hypothesis.
So we can't
That there
just
is an
look
effect.
right at the p-value as 7.16.
You 100% can. I'm explaining to you that the p-value, you got this because of the difference between these two. I'm giving you context for it
Right.
because they're related. Yeah.
Okay.
Yeah. Questions about this? Okay. On the exam, be prepared to know how to do one of those analysis. That'd be the special project, something you guys will, I'll give you a ton of data and you'll have to run an analysis. And on the exam, be prepared to answer, if I give you a table like this, what does it mean? Is it statistically significant? And what would be your response in regards to the null hypothesis? Okay, questions?
Okay, so our exams in 2 weeks?
Yes,
All right.
2 weeks. So let me stop this real quick. Where am I anyway? Why is this still here? Okay. Oh, I lost you guys now. Are you here? Okay. So I'm pulling up here our Course Connect. Next week, we're going to go over regression. And then after that, that's it really. Then we have our Thanksgiving break and the exam, which is going to be part exam, part special project, where I give you a big data set and I give you different analysis to do. Okay.
That's in 3 weeks, right? Not 2.
So next week we have lecture, that's regression. The week after that is Thanksgiving, and then the week after that is the exam. Yes, I think you're correct, Greg. Did I say it wrong? I may have said it wrong.
Just making sure. Thank you.
No problem. Question about the grades. Are you guys all seeing your grades now? Because I had talked with IT, and I think we had fixed it. Everything is still doubled up. Don't know how to fix that, but I think it should be visible now. Yes, no?
Going now.
It's working for me. I'm seeing them.
Thank you, Jenna, for telling me. Because I was like, oh no, it didn't work.
Perfect.
Okay. All right, that's what I've got for you guys today. This is a meaty topic, so I don't want to add any more. Regression's going to be meaty too, so I like to split these guys up.
So what's due for next week?
Let me pull that up. I don't think there's anything that's due next week.
Okay.
Let's
And then
look.
can I also ask you a quick question after class?
Sure.
Okay.
Your lab was due today, and we will have a quiz next week.
Okay, so
Okay.
the lab that was due for today, we emailed you, right?
Either way, you
Okay.
could have put it in Course Connect too.
So which Course Connect tab did you want us to drop it into?
I put it under lab 4.
Okay, because Lab 4.
Yeah, Lab 4.
Description of it.
It says yeah.
Yeah, and then like when you click it, it says like turn in the 4 variables, like.
Oh.
And then we also have the cross data that actually.
Yeah,
has
no.
that stuff. Okay.
You guys did that already. Yeah. I don't know why that's. You guys, so many questions. I don't know why that's there. No, Lab 4, you're good. That's what it is. I don't know why it says that.
Okay, awesome. Thank you.
And then we'll have a quiz then next week that'll be over what we just covered today and a little bit of last week.
All right, awesome.
Okie dokie. You guys have a great night. I'm gonna stop the recording and then somebody